Hello and welcome back to the commercial space business track. Things are looking a little sparse here, but we'll work through it anyhow. Our Revolutions in Global Communications panel, we have our three distinguished panel members, Bruce Krasolsky from Constellation Communications, his co-chairman, Dr. Peter Swann, manager of the Washington Systems Office and senior systems engineer for Motorola, will talk to us about the IRIDIUM program, and Mr. Alan Parker, or is that Dr. Alan Parker? Mr. Alan Parker,
Dr. Swann over here,
president of Orbital Communications Company, which is part of the family of businesses at Orbital Sciences Corporation. And what's interesting about these three speakers is that their companies represent three of the most cutting-edge future communication systems, space-based communication systems, distributed small satellite communications capabilities, which is a divergence from the current successful geostationary-based large satellite communications market. And these three gentlemen's companies are right on the cutting edge of developing a whole new market that is going to revolutionize the way you and I talk to each other over great distances. So, without any continuing discussion, I would like to introduce Dr. Swann to come up and talk about the IRIDIUM program. After each speaker, we'll hold questions until the end, and then at the end we'll have a Q&A session after all speakers have gone. Thanks.
Well, we'll start with a small crowd and see if it gets bigger. The IRIDIUM program is a program that came up and started with a very simple set of requirements. And we believe that those are the only two requirements that count, and everything is designed to satisfy those requirements. The requirements are basically, you must connect to a handheld telephone that you can put in your pocket. And I just happen to have our mobile subscriber unit mock-up right here, and that fits in your pocket. The second criteria is even simpler. It's profit. There's a very simple way to measure profit. It's either real or it's not. It's either red or black. You're either making a profit or not. So those are the only two criteria items that we use as a measurand of success. And we've been designing the handset here for a while. It's gotten down to a pretty good size. It connects to the satellite, and the profit issue basically is the market. And so I'll talk about the commercial aspects of low-altitude satellites and telecommunications, and I'll specifically talk about the IRIDIUM satellite system. But there are many other alternatives. We have chosen as the mainstay of the business, voice, any place, anytime. The essence of it is that the system provides high-quality digital voice. We're using the advanced technologies of digital. We're doing switching in space, but it's a very simple process. It's voice, point to point. It's a connection between this handset and any other telephone number in the world. Great. The system is a constellation of satellites. A unique aspect of IRIDIUM is the crosslinks. We have crosslinks in each plane, front, back, so that's a constant connection around the globe as they go around in orbit. The connection goes to the satellite in front, the satellite in back, and then it goes left and right. It connects, therefore, to 4 satellites. Each single satellite connects into 4. Now, the left-right connections are basically between 60 south and 60 north, because as you approach the poles, the rates of antenna pointing get to be too complex. And so we only do it during the 60 south, 60 north portion. Why are we doing IRIDIUM? Well, I started out with the basic ground rule of profit. And the real key is there a marketplace? And the answer is yes. The coverage will provide a global dial tone, any place, any any time. That does not exist in a significant portion of the world. Think about going fishing in Wyoming. Think about going to conduct business in Zimbabwe. There is a tremendous part of the world that does not have a reliable connection where you can just punch a number in and have it work. The cost is critical. To make the second criteria of profit, you must have your low cost. Next slide, please. The IRIDIUM is a very simple, straightforward system. It has a constellation of satellites that you connect from the ground to any other telephone number. You have a system control facility which controls the satellites. It ensures that the satellites are still operating. It sets up the maintenance procedures. It makes sure that the batteries are charged in the solar orientation of desire, et cetera, et cetera. The system control facility will probably have a primary and a backup. We're still working on a lot of those designs. The gateways are the connections between the telephones and in the IRIDIUM system, the handheld units, and all the other telephones in the world. It connects through the public service telephone networks. It utilizes the telecommunications organizations and agencies in each individual country. We will have to come up with 180 licenses for each of the countries. It turns out that the connection into the countries is through a digital downlink at K-band, and then goes into the gateway and is dispersed throughout the country through its standard public service telephone network. The picture here shows how the crosslinks work and how you connect to a gateway and how you connect to the handheld unit and to the mobile unit in a car, and how the system control facility goes up to the satellite and controls all 77 satellites continuously through the primary ground facility, space control facility units in the backup. Next please. Subscriber equipment. To succeed in the second criteria, which is profit, you have to give the market a flexibility. So we're providing a telephone service that basically can do all the different aspects that your telephone can do today. Fax, data, modem, computer to computer. One little interesting concept which we think is intriguing, which we believe will sell rapidly in the developing world, is a solar-powered phone booth. You take an IRIDIUM handset such as this, you wouldn't have to be as sophisticated. You could make it a lot simpler, a lot cheaper. Nail it to a tree, put a battery next to it, and have solar cells charge the battery. And you've got a phone booth. And you can put that any place in the world. And so you can provide connection between any government and any village, any business, to any office through a community phone booth in any village. Next one. The handset is designed to be dual capable. The reason we have a dual capable handset is that the connection to your local cellular network is less expensive than the connection to a spacecraft. So what you're going to do is you're going to dial up. As you dial up, the system will choose the less expensive route. If you're inside a cellular network, terrestrial cellular network, you'll connect through the terrestrial cellular network. If it does not connect in the terrestrial network, because you're using a different protocol, yours is Washington, D.C. based, and you're in Tokyo. If your system is not compatible with the local network, it will go up to the satellite and take the other route. So you will always have connection between where the handheld set and a cellular network. First choice is terrestrial, second choice is space. Go ahead, please. The question of the market is really where the profit issue becomes important. We've done a lot of thinking, and it boils down to a very simple statement. If you need to communicate, you'll probably like to have voice communication. if you need voice communications, any place, anytime, basically ask the question, what is a person doing? And if you answer that question, then you'll need to know what the market is. An example, marine. If you're trying to sail across the Pacific, it sure be nice to have connection. In addition to, the handset is geolocated continuously by the satellites, so you'll know where you are, as well as being able to connect. Pleasure boats, commercial air travel, general aviation. If you're in an aircraft and you are traveling all around, going across country or something like that, you have continuous communication, any place, anytime. Next, please. There are all kinds of applications that come to mind. Truckers, ambulances, oil rigs, oil ships, airplanes. One of the largest sources, we believe, is going to be the DoD casual conversations. In other words, when the DoD is deployed, they still like to talk back to the wives, spouses, friends, etc., family, mothers, and so you can connect through a commercial connection and not load the DoD network. Market assessment. Now this is where Motorola has a tremendous advantage over many, many space companies. Motorola is 92% commercial and only 8% DoD. We do a tremendous amount of work in cellular terrestrial networks. We do a tremendous amount of work in pagers. We do digital. We do telecommunications. We do wireless communications. That's our business line. We are global. The reason we went into this business is we saw a profit in it. The bottom line numbers are for cellular global, that's terrestrial cellular, and for paging global. And the growth rates there are 25% and 18% per year. Tremendous growth rates for a market. We see IRIDIUM just complementing that type of market. These low altitude technologies are going to provide the capability to connect anytime, any place, and the market will expand. Motorola came up with the idea of combining low-altitude satellites with voice, cellular, telephones. The reason we came up with that idea was we had a gentleman named Barry Bertiger in Arizona who had worked in space for like 20 years. And he was loaned out to our cellular division to help with the systems connection problem with terrestrial cellular. After working on that system for a while, he came to the realization that indeed you could connect to a low-altitude satellite 400 miles over your head with a handheld 4-inch stub antenna. So that realization led to the exploration of an opportunity. Would it be profitable? Could you do it? Could you provide the crosslinks? The crosslinks are essential to the concept of being able to connect any place, anytime. The technologies were emerging. The timelines were such that you could achieve a profit in a reasonable time. So Motorola proceeded with that. We're the prime on the space engineering side. We plan on, currently, we're the sole stock owner of IRIDIUM Incorporated, which will be the consortium that owns and operates the system. We will plan to go back to 15% ownership of that organization as we bring in partners. We will supply gateway hardware and will manufacture handhelds and license technology to other manufacturers around the world to increase the competitive nature of the handheld and the voice connections. Go ahead. Oh, that's kind of hard to see, isn't it? Okay. Basically, 92, we're going to have a consortium formed. 94, we're going to fly some experimental satellites to test out all the concepts, including the system control facility, up and down gateways, crosslinks, things like that. 95 starts the launch of satellites, and 97 is fully operational, January 97. I can't even read that, it's kind of hard. Next. The interesting thing is, why did it occur now? Courtney Stadd talked about the opening up of commercial space. That was indeed an important aspect. But the revolution in electronics has been going on for years. What's occurring now is the ability to implement that electronics revolution in space. It takes a while to get parts space qualified. Small, smart spacecraft growth industry. Alan Parker will talk to you about the ORBCOMM system. Orbital Sciences has been a pioneer in this area. There is a tremendous opportunity there. IRIDIUM is just one of many. Less expensive commercial launch industry. Orbital Sciences, once again, is at the forefront of that. There are many companies trying to develop the commercial launch industry for small spacecraft. That's occurring, it occurred in the last half of the 80s. It's expanding in the first half of the 90s. Cellular telephone market exploded well beyond Motorola's expectations. We're glad it exploded. It's great for business. We plan on it continuing to explode, and we plan on supplementing the terrestrial with this space organization. The global information needs, the creation of the CIS, the freedom to ask questions, the freedom to connect, the freedom of Lithuania and Estonia to call direct instead of going through a Soviet phone system. The need for information is just exploding around the world, and a system like IRIDIUM will provide the ability to connect from any place to any other place and ask the tough questions. Can you conceive of a school child in Vladivostok calling the Smithsonian Institute to ask a question? I mean, that type of thing could occur. Of course, the bill will show up on the school's doorstep, but those are minor little things. Next. The other thing that's occurring is the political tensions are lessening. There is more transportation. There is more mobility around the world. The economic opportunities are opening up in the whole CIS. They're opening up in Eastern Europe. The information exploding is, information revolution is occurring at faster and faster speeds. The IRIDIUM service will truly revolutionize the capability to connect throughout the globe. Yes, next slide. The global personal communications is a catchword within Motorola. We believe that personal communications is where the wireless communications will be in 10 years. You will have a telephone number. You will travel wherever you want, and that telephone number will be with you. AT&T just announced, I love to advertise for other guys, but AT&T just announced a 700 number, that you can pay X dollars for a 700 number, and it will travel and follow you to work, to the gym, back home, to your car mobile phone, to travel to the hotel, etc. And the concept of personal communications is a revolution that will occur over the next 10 to 15 years, and IRIDIUM will be in the forefront to provide that personal communications around the globe. Thank you for your time. Next, you want to do questions now?
No, well now we'll have Alan Parker come up. And next we have Alan Parker talking about the ORBCOMM communication program.
Thank you very much. Following Courtney Stadd and Dr. Peter Swann is pretty hard to do for a kind of tiny little company, right? Harmless little company.
That's so tiny.
Yeah, well, Orbital Sciences has indeed grown in the 10 years since it was founded, just a little over 10 years in fact. And last year we had revenues of $135 million, 30%, 35% over the previous year. And we're still growing at that same rate. We passed a milestone for ourselves. We now have over 1,000 employees located throughout the United States. I'm one behind you. All the things that Peter said about the drive, the belief that personal communications and other types of communication systems, allowing one to communicate from anywhere, to anywhere, from any place, no matter where you are throughout the world, is a time that has really come. And that's built on the tremendous growth of mobile communications that certainly was pioneered by, and in fact in some areas dominated by Motorola, who had a long-term vision that was certainly a superior business than televisions, right? And they certainly have done well in that regard. So we certainly didn't invent in any way. I wouldn't make any claim whatsoever to the notion of worldwide communications. But we had seen about 5 years ago, even preceding my time at Orbital, a real opportunity to make use of the technological trends that Peter indicated to you, to address a market opportunity and a new service which in fact does not exist anywhere today. It does not exist because none of the systems that are there today provide a low-cost, practical way of reaching those markets. This is not a voice service. This is a data service, and the need for extremely low cost has driven the architecture of this system and its design, and it drives our vision of what the future markets are. Global, two-way message and data services. Having said global, I want to contrast ourselves somewhat with what Motorola and IRIDIUM and some others are doing, and say that our focus clearly is on the individual countries. We believe that 90+% of the, probably approaching almost 100% in many cases, of the message traffic will originate and terminate in the same country. So our whole architecture is also driven by that nature, by that notion, and that is only one important reason why we wouldn't have, in our case, inter-satellite links. I know this is a somewhat technically interested audience, so I'll try to sprinkle some of these things in there. In any case, we believe that we should have a right, really, to use the phrase vital communications absolutely any place on Earth. Next slide. That introduction, I'd like to just give you a flavor of what has happened in the U.S. wireless communications business from 1980 to what we project down to the year 2000, and of course an actual point there in 1991. Specialized mobile radio, which certainly Motorola is clearly the dominant player in that market. It's mostly voice, but they early in this decade there was an important change in regulation at the FCC, allowing these units to be connected, very high tower, wide area, regional units, to be connected with the public switch network, making it kind of like an industrial cellular business. And Motorola certainly seized on that and has driven that into a very stated. It ran mobile data and coverage plus at Motorola continue to grow at the pace they are. There are some issues with that, and I'll get into them. Pagers in service are 11 million. Everyone thought that the cellular business would kill paging. In fact, it prompted it to grow faster. And paging now is making its way out of the blue collar and the medical model into homes. Parents with little kids are renting them to go to the concert so that if there's an emergency they can be called out of their seat with a vibrating tone type rather than the believer. But that's projected to continue to grow to 20 million, and now the advent of services which are close to paging, Embark, I know Motorola wouldn't call it a paging service, an information service, and a wide area. It's not truly nationwide, but wide area alphanumeric paging is growing rapidly. Now there's the star over there, is cellular subscribers, and I would make no claim whatsoever to say that the system that we are planning and implementing is really going to penetrate or make any impact on any of this. It's just background. This is what's happening, and awareness drives markets, applications. It all also drives clutter. So what you bring to this market, you better make darn sure that not only does it work, provide high quality, but that the benefits are clearly stated. And in the land of the giants here, Orbital Communications Corporation is very much aware that it's the difficulty of forging a new service offering on a worldwide basis, no less, in an area that has names like McCall and Lynn and AT&T and Bell South and Motorola, etc. Next chart, please. What is ORBCOMM? I'll go across the top. It's a very low-cost, two-way data mobile satellite communications system. We provide and will provide communication links between terminal units and customer offices using VHF. And that's a very key distinction, and it drives the entire architecture and satellite design of this system. That is contrasted with what are called the large or big LEO systems like IRIDIUM, Constellation, Loral, Globalstar system that use L-band, 10 times the frequency. They have different propagation characteristics. VHF happens to be ideal for the application that we foresee, and it will never carry voice. That is, in fact, precluded by, and will be precluded by U.S. regulation. So that's not an issue here, and it's not an issue in our business plan, frankly. It was never an objective of ours. The terminals are obviously mobile. They can be pocket or installed in a vehicle or a boat, whatever. They also provide position determination, not GPS quality, not as fast and not as accurate, but very, very inexpensive using Doppler. And we use 2 channels for the highest definition Doppler, a la the U.S. transit system, but indeed an updated version. Most of the time, the terminal will always be in sight of a satellite, and sometimes in sight of 2 satellites, and that eliminates the uncertainties of delay that are involved, and lack of accurate information and ephemerides from the satellite that are experienced by the U.S. Navy transit system, which will end life at the end of 1996. The system is data, as I said, and I would say that in the main, a fairly long message for this, but not atypical, it would be 50 characters. Most of the transmissions will be indeed more of the coded type macro messages. Qualcomm has used some of this very effectively to reduce the cost to the customers, but also to increase the capacity of the system. Now we can command a terminal to the terminal, outbound to the terminal. We can send messages, we can send requests, and we can confirm receipt of messages to the terminal. From the terminal units, inbound, random messages of data, or in response to requests or polling. It's very important, and that two-way distinguishes ourselves from other units like COSPA-SARSAT and very rudimentary services such as Argos. Terminal units will cost retail from $100 to $400 depending on the feature level, and the largest manufacturer that we're working with, an advanced, the worldwide company, Panasonic from Schuster, projects that the average cost of the terminal, I mean this is after a year of working with us, will be somewhat just above $150. Depending, obviously, that includes a lot of mix of emergency services with fairly minimal features. Access charges $30 a year for emergency, up to $45 a month, closer to the alphanumeric paging, but for two-way. And the usage charges for that two-way alphanumeric paging would be akin to the nationwide paging services today in terms of the messages. Next slide, please. What is the components of the system? The first 2 satellites that we are, in fact, under construction, under contract, and they're building now, and may I say that's going very well indeed. We have a fairly long pre-programmed R&D effort on those spacecraft. The spacecraft look nothing like they're shown there. Unfortunately, this time, for competitive reasons, I'm not able to describe those, but perhaps by the end of the year or early next year we will. I think you'll find them just absolutely entrancing. I have a satellite background, and so I keep looking, even though I'm a services type now, I am curious about the hardware, and it is rather exciting what we're doing, in my opinion. That is self-serving, obviously, but I think the world will someday see that. We are in a contract for those first 2 satellites based on a license received as an experimental license with developmental authority, a la the GTE airphone variety. We can actually proceed to sell and market the services. Therefore, we're able to capitalize the cost. Very important for us as a company that can't stand major hits to the bottom line, perhaps sustainable by some larger companies. That's Constellation in 1993 will be comprised in mid-93 of 2 satellites in near polar orbits at 785 kilometers. They'll be launched on the Pegasus. You'll see a picture of it in the upper right. Orbital Sciences is building the satellites. They're obviously building the Pegasus that will carry them to orbit. And we are also building the component on the lower right, the Gateway Earth Stations. In the United States, we'll start the service with 4, and that will be sufficient for the later deployment of additional 24 satellites in 1994. So by the fall of 1994, we'll have a complete network covering all of the world with very high availability, especially in the 25 to 50 degrees north and south latitudes, which it's aimed at starting in the United States. That's the service. We'll have those in orbit and operational. There'll be 4 Gateway Earth Stations. You'll see 2 antennas at each, and they are indeed large. They're, the final versions will be that covers the, I've lost the, what do you call it, radomes. The radomes will be about 30 feet in diameter, and that's driven in part by the low frequencies, the VHF frequencies, and the need to project at the satellite about a 15-degree arc of coverage in order to avoid interference with other spacecraft that might be operating. Network Control Center is well along in its development. We're using a very advanced case tool. You can see some of the people sitting there at the workstations now. We have 5 in service. There are 2 more being delivered in the next few weeks to increase our capability for writing the software. We have already developed and crashed and tested the inbound links from the user terminal, a hypothetical terminal, through the Network Control Center, and next week we'll reverse, using this case tool, we will reverse engineer the 14,000 lines of code written by this in C language and send the messages outbound. So we're very excited about the development there. And in Maine, surprisingly enough, we're ahead of schedule, and there's a total of 5 people working on that. So you can do a lot with a few folks who know what they're doing. The area that we're not developing, except for the software that will go into this terminal, which will mate it with the transmitter and receiver, which we will provide as one of our services to manufacturers. We are licensing and type approving the manufacturers. Schuster Panasonic with us this week ran the first test through the test satellite in Boulder, Colorado. Those were completed, I'd say about 90%. We had one small glitch, but it's a type of thing you would expect, and we'll work through that. But it was really an exciting week for us in that respect. So we're ready to now have test units that will be demonstratable later this year to potential customers, and of course for further development of the system. We have now brought on another subscriber terminal manufacturer into that program, and I'm not at liberty to announce that one at this time, but we will in the next few weeks. This is perhaps one of the first times, if not the first time, that one company will have developed and manufactured not only the satellites, but the launch vehicles and the Gateway Earth Stations, at least for the United States gateways, and the Network Control Center all within one company. And we're doing that basically in a program which is about 17 to 18 months. If that worries you, it worries me, but it looks good right now. And if I sat here and said no problems, you probably wouldn't believe it anyway. But In the main, I think it looks certainly near green across all those faces, and we're very optimistic about it. That first program will cost us $22 million. The $20 to $22 million is in the bank. The company has no debt. We have $30 million in the bank. We raised the $22 million, $20 million last year in a stock offering. We are in the process now of bringing on and soliciting minority partners, worldwide partners, who will make minority investments in this for strategic reasons. So they truly are strategic partners. We're not interested in just the banks or loans. That, for us, doesn't do the job. Okay, next slide. You may want to see where we are heading. In 1995, we will almost certainly, depending on the response of the first 26 satellites, launch another plane of 8 satellites, also at 45-degree inclination. And we're optimizing the plane distribution for the first 3 planes of 24 in the main constellation to accept this at minimal degradation in 3 planes over the United States. But it will optimize and increase the coverage, especially in the regions north and south of the equator, where a lot of the underdeveloped nations are, the third world, so to speak. This looks like a geostationary pattern. In fact, it's driven in quite different. It is an availability pattern which depicts, with 4 gateways at the corners of the CONUS, the availability at any point to a subscriber who may wish to communicate of coincident availability of a satellite in one of those gateways. And you'll notice that 95% plus in the dark area. And you see there's a fair amount of availability off the East Coast. Well, we're working on that in later runs to reposition especially the Northeast gateway to move some of that availability a little closer in. We talked about this. Next slide, please. We talked about the subscriber units. Anyone wants to see what one looks like. Anyone caught holding this to their head is instantly declared non-technical, because you don't speak into this. This is a data terminal, but it does give us some advantages from the standpoint of power. These are 2 5-watt units. You don't want to hold a 5-watt to your head. I believe it's 0.6 of a watt for the Motorola type of units, and the others that are portable. The simplest version is SecureNet and emergency service, about $100, and the most complete, the VitalNet. Next slide, please. Everything we do is done to build on the existing infrastructure. I'm sorry about the spread of this. There are copies here. Got a little either too far back or whatever. But ORBCOMM is an overlay. And its network control center and these units are mounted in a mobile situation. It is truly an overlay on the system. It has 2 functions in that sense. It provides another source of message origination and another source of message destination. But you can also send it just like you could any email message or any page, if you're familiar with Bell South Mobile or Skyward, SkyTel. You can use a computer to send those messages. And in our case, we'll have operator interfaces as well, like Bell South MobileCom has. So we're not reinventing the wheel. What we're doing is extending the reach of the telecommunication system, the PSTN, PSDN, to areas that simply have no coverage whatsoever. Next slide. The interconnections are very well known. Telephone access to a computer mailbox through a modem, X.25, X.400 will put us inside the email networks, telex store and forward, facsimile, and operator assisted. No invention here. If you say, well, so what? To us, that is very good news, because that means we don't have to develop anything. All our protocols will be matched to those at the network control center. The internal protocol, of course, is new to us. We can't afford X.25 type waste in our system. It's not enough bandwidth. Go to the next slide, please. The markets are extensive, and if it looks like a different version of a Motorola slide, I think that's a correct characterization. However, our view is that we will fit well below the in terms of our cost of our equipment, and we believe that we'll be in the market significantly before Motorola. At least that's our target. Actually, if you would say there is a target, we would like to be in the market at the same time. AMSC puts a satellite up and has a service to some of these markets, albeit at higher cost. I'm not going to go through these in detail, but there are emergency services, data acquisition, tracking, messaging. The early year, most of the revenues will come from messaging, although the first starter services will be in data acquisition and tracking. Next slide, please. An important part of our effort is long-term is to become part of the OEM, automotive regular production option component in the car. And we are in discussions with automobile manufacturers around the world, this country, about this. These systems, because they are near FM, can share the exterior entertainment radio with the AM/FM radio. You can actually share some of the components of the radio, and in fact that's what is in mind there. So we mean to long-term become an emergency message service option. $200 suggested retail, $75 a cost built into the car, leaving about $91 for the company itself. The service charges would be on top of that. Most of the systems we believe would be like in the lower right, the micro message center with some signaling buttons, ability to send and receive a message. I need help, I need a tow, my car is on fire, medical emergency. There's lots of infrastructure to be put in place there, but by cooperating with these kinds of companies and forming alliances, we hope to penetrate that long term. Now let me go to the next slide, please. Competitive advantage is something, I'm sorry, the hybrid, I skipped one. These are potentially very important markets for us. We do not plan to be everything to everyone, but we do believe that there's a large, untapped, unaddressed market for things like gap filler and complementary applications. I think it makes some sense in some applications for some markets to combine pagers with ORBCOMM system. If you're in a building, you get your page, you answer by phone. If you're someone who travels outside, in construction or whatever, you're outside the service area, or you're inside the service area, you want to respond right away, ORBCOMM can do it. Of course, we have an advantage. With ORBCOMM, you know the page page responses, but it's not an easy task, and it's going to take a while. SMRS data is a potentially very big one. I'll address one in a minute. But grant mobile data, or for that matter, artists, or Coverage Plus. Building towers all over the country to cover every bit of the country is indeed an uneconomic solution. Somebody's going to fill that gap. Obviously, Motorola intends to fill that gap later on. However, we believe that we're going to get there first, or at least that's our target, and that we hope to have a much lower cost solution for that. For those simple, for some part of it. If you want higher speed, higher data rates, fax type things, that's their business. That's not our business. If you want it down into the consumer level and perhaps much smaller business level, and that's where that's good for us. Okay, cellular data is just emerging now. Cellular Plan 2 has been announced as a coming thing next year in 1993. And again, we'd be happy to work with people who make cellular telephones if they want to give something to their customers where they can, in fact, message to some extent anywhere in the United States, any place, mountains, desert, whatever, offshore and boats, that's us. Complementary applications, GPS and palm-top computers. Palm-tops are email systems, they're not word processors. And there is a move, there is a Motorola data stream modem which has been released and announced by HP for this HP 95XL. And that we're watching that very carefully. And of course, in the GPS field, we think that we're just ideal. I said we could position, but for someone who has a GPS receiver, if they want to communicate their position, how do you do it? You have to have some means to do that. Now you could do it with cellular or something, but cellular isn't everywhere. Okay, next slide. Most important slide of all. In this land of the giants, how do we make our way? Well, we rigorously pursued a regulatory approach to get worldwide allocations for this new service, and we were successful at work in convincing and working with the U.S. government and other governments around the world for primary allocations up and down link every place on the face of the earth. That is a breakthrough for us of major proportions. That allows us to operate worldwide. I'll say more about that in a moment. The total system that we're building, including the 26 satellites, will cost us about $100 million total, all in, all engineering, all non-recurring, and all variable costs associated with the satellites. With that, we will be able to address from space 3 billion pops in the parlance of the communications. That's almost ridiculous. As a matter of fact, I hesitate to put the number up there, but it's all people on the face of the earth, maybe there's 4. I don't know how many there are now. The 100 million, I want to caution you, only has 4 gateways. If you want to offer this service in Mexico or Brazil, you have to build some gateways, but the investment is indeed very low. Brazil or Canada with 3 gateways would have an investment, including pre-op costs, of maybe $5 to $7 million. And for that, you address every inch of your country. RAM Mobile Data is building a system in this with Bell South at $400 million. They could address maybe 80% of the population of the U.S., 200 million pops. Of course, that's kind of, that service, the data service, is mostly irrelevant in terms of pops, but it gives you a measure. Two-way communications at one-way paging prices. $300 for this terminal, or something akin to it, is very much in the cards. And of course, if you want to buy a Motorola Bravo Advisor alphanumeric pager from SkyTel, will sell to you exactly $300. Now, there would be discounts in the markets, but I haven't shown that kind of thing. Would you rather have two-way or one-way? It depends. If you want building penetration, you're going to have the page. If you don't want building penetration, then it's not important to you. You really want to talk about where most people are concerned when they're out on a job or traveling, then we can provide two-way. And the last part is comparing us against other existing two-way ubiquitous service companies. And you have AMSC coming along, you have Inmarsat-C through AMSC, and they range in their cost from maybe $3,500 to $10,000, very big units, big antennas. Ours are $300. What would you buy? Actually, our data rates are higher. Qualcomm you could put up there, it's $5,000 in one-off units, $4,000 for the software that you need to have in your plant, and they operate at considerably slower data rates. We operate 2,400 bits inbound, 4,800 bits outbound. Next slide, please. Just a quick look at what we would. Do you think there's a market here if RAM wants to advertise? If RAM wants to advertise universal coverage? Well, I think so. Not all those trucks just stay in those gray areas. And I hate to say it, Peter, but the artist coverage looks pretty much the same as that. The coverage plus isn't that good. Okay, the next slide, please. Now, where are we in the price? The left side is the equipment price, on the bottom is annual service charges. The white areas, including IRIDIUM, of course, and ourselves, we're not in space. We're not in service. We haven't sold one bit yet. So you're really projecting on the come here. And it's rather dicey to plan these kind of systems. It takes a lot of confidence that you feel you're right. The others are in service. AMSC is selling Inmarsat-C. Qualcomm is in with a K-band service. Artis is there. Coverage Plus is not on there, Peter, but if you have any, tell me where it is. I'd be happy to put it on there. Cellular voice is shown. That data is nearly not available. It's irrelevant today because it's all dial-up. And then RAM mobile data about $1,000 to $1,500. Now, I'm going to strip out those that are tower-based that can't cover those white holes that you saw in the previous chart. Next chart, please. Okay? A lot fewer competitors show up for those markets because you can't get there. Now, our idea is to get there at extremely low cost. I have no idea where 1990X data for IRIDIUM service is going to be priced. I just don't know. If you can point that out to me too, Peter, I'd be happy to put it on there. Or Constellation, that'd be great. AMSC says they're coming down in that range. I don't know how far. Qualcomm's going to have a hard time moving down. I think in volume they sell those for maybe $3,500. In Europe, the Utel-Trax unit is $6,000. It's not $5,000, it's $6,000. So, okay, the next slide will tell you just in one quick look at what we view. This is an example of an application of this system to Indonesia. You'll see 3 gateways, one on the left, one in the middle, one on the right. That's about what we think it would take for Indonesia. They've used Palapa VSATs to link back to the headquarters in Jakarta. And of course, out of the country, messages would go through the regular PSTN, Intelsat links, etc. But we could essentially, with this system, provide low-cost communications to every place in Indonesia for approximately an investment of $5 to $7 million. We will receive our revenues from that on service charges only. We will receive a portion of the revenues. This is the advantage. This is the power of low Earth orbit working for you. We will pay for the system and amortize its investment in the business that we'll get in the United States. That may be unique to ORBCOMM versus the big LEO. I can't tell because I don't know the business plan, but it is in our case. If we serve no other market than the United States, we have a business. So the rest of the world, to us, is largely incremental. The interest in this at the WARC was dramatic. And those who spent time there, we were hoping to just sneak in as a little, oh, by the way, and the damn thing became the centerpiece of almost a lightning rod for the big LEOs. But so be it. We got what we needed, and I think we're on the way.
Thank you very much. And now we have Bruce Krasolsky, co-chairman from Constellation Communications.
Good morning. Thanks for coming and bearing with us. What I'd like to do is provide a bit of an overlap and maybe fill in some of the gaps that the two previous speakers have already addressed rather than simply repeating a lot of that presentation. Let me start by saying that in Constellation's case, we are in fact a competitor with IRIDIUM. We do not view ourselves as a competitor with ORBCOMM. It may be helpful to distinguish those two markets, at least from our perspective. And I think probably the best way to do that is the low Earth orbit systems that are looking for business above 1 gigahertz of the radio frequency spectrum, and then those that are below 1 gigahertz, such as ORBCOMM looking at the VHF portion of the spectrum. Smaller bandwidth in the VHF portion of the spectrum, focusing on data. In the higher bandwidth, the L band, which are the big LEOs, we're focusing primarily on voice and higher data transfers because we have more spectrum. Next slide, please. Constellation's approach to this market was essentially as a startup. We saw an opportunity. This is truly the land of competition, and we feel like we have a better mousetrap. Take nothing away from Motorola's efforts in paving the way, actually, in fact, waking the world to a new technology, a new opportunity to address what we consider an unserved market and with tremendous potential. We see this as an opportunity to take advantage of the convergence of three different factors. First is a mobile communications revolution where... Better? I'd always shake somebody when somebody comes up to me. There's a microphone. First is the mobile communications revolution. There was a figure earlier presented where that market is anticipated to be growing at approximately 25% per year. Some of the Bell companies and some of the independent studies have even indicated that it's higher, perhaps 30-35% worldwide. It's in fact the fastest growing market in the world. Lightweight satellite technologies, the advances that have taken place in the last 5 years in satellite technology, and I'll get into that a little bit more in a minute, have enabled for the first time low Earth orbit communications in both the data and the voice and other applications as well. And then also the thing that brought this together, that made this an opportunity now, was the opening of new frequencies. As far as the big LEOs are concerned, the vacating of a band by a company called Geostar that had an excellent idea and but wasn't able to take advantage of the market, left a tremendous gap in frequency in an area that is primed for providing low Earth orbit mobile services. Next slide, please. To expand just a little bit on the market potential, you can look in just about every country, particularly the United States, but also developing countries, and see that voice, data, fax, broadcasting, position, location, with the environmental movement, remote sensing, a tremendous need for new communications, for information flow, and low Earth orbit communications because of the lower cost and the ubiquitous nature of the technology allows you to take advantage of that. Next slide. Also, the political changes that are occurring in the world, particularly, for example, Eastern Europe comes to mind, but if you look at the developing countries, the fact that they're privatizing their telecommunications networks, they're looking for foreign investment, they are eliminating what were for decades barriers that would allow only the local telecommunications monopoly to provide access to the user populations. They're now opening all of that up. They're looking for international strategic relationships to join in expanding the telecommunication services offered to their citizens and to the governments that allow the countries to function properly. Next slide. I'll address those. From a technology standpoint, the advances in technology that I'll talk about in a minute allow really for the first time satellites to address these markets that are right now unserved by the existing terrestrial networks. The landlines that have been painstakingly laid by hand cables stretching from point to point throughout the world miss a tremendous amount of area, not only in the developed countries, but most particularly in the developing countries. And because of the cost of establishing landlines and even establishing cellular networks in less than dense areas makes low Earth orbit technology a very attractive alternative. And Motorola and ORBCOMM and Constellation of others have seen an opportunity to take advantage of this. The first time, because of the lower power requirements that low Earth orbit systems allow, you can use handheld terminals. And that makes it very attractive to previously unmet population worldwide. Next slide, please. Well, that's kind of tough to see. I think it's important to step back for a minute and look at what I consider a little bit of an irony. If you look at the development of satellite communications over the last 30 years, and they started in the early 60s with what is now the global organization called Intelsat. And prior to establishing that system, which is based on geosynchronous satellites at 22,000 miles above the equator and cover at best regions of the world because they are essentially fixed over a particular point, there was a big debate as to whether to use that particular type of technology or in the alternative to use scores of low Earth orbit satellites as are very similar to those proposed here to address the market that way. And 30 years ago, while low Earth orbit communications were perceived as an interesting alternative, for cost matters as well as the technical capability that existed at that point in time, it wasn't feasible. Well, 30 years later, although geosynchronous seemed to be such an elegant alternative because you had only a few satellites, they were high enough that their footprint on the face of the planet could cover up to a third of the Earth with a single satellite. It looks now that because they're so high above, because their power requirements are so great to establish a communications link with the ground, they're really not feasible for mobile communications. Now, there are some attempts, like American's AMSC, that may or may not be able to overcome that. But if you bring that satellite down from 22,000 miles to something closer to 550 miles, then you bring that down an order of magnitude in distance, and you bring the power requirements down an order of magnitude. When you bring the power requirements down an order of magnitude, you reduce the weight of the satellite, you reduce the cost of the satellite, and when you reduce the cost of the satellite, you reduce the need for redundancy, or multiple redundancy. So ultimately, you can afford a much, much smaller package, which makes your overall system much, much less expensive. And You couple that with the advances that have occurred in the last 10 years in microminiaturization, stronger materials that are lighter, computer technology, and for the first time, 30 years after the concept was originally formed, you really can bring it into reality. And that's what these companies are about to do. Next slide, please. The third factor of the equation is the FCC frequency allocation, and then the more global worldwide allocation that's available to these new services. From Constellation's perspective, and I think generally from any kind of a new entrant into the communications business, the FCC is truly what I consider to be the great equalizer, because the FCC has an administrative process that allows for any company that has the technical, economic, and legal requirements met to compete for that particular spectrum. A particular company right now, anyway, cannot own the spectrum. The FCC allocates it based on public interest and public need. And traditionally, ever since the FCC licensed the first private commercial satellite in the United States, the foundation of that licensing policy has been to promote competition. Essentially, rather than choose a particular system because the FCC decided that it was politically correct, the FCC has attempted, whenever possible, to license every applicant that was qualified, and then let the market decide who wins and who fails. Well, when the Motorola application was filed, and before that, when the Ellipsat application was filed, those were the first two applications in the FCC Big Leo process. The FCC allowed a window of 60 days for anyone else who had a competing technology that they wanted to propose to file an application before the FCC. So Constellation, along with ORBCOMM and TRW, filed competing applications. So now there are 5 low Earth orbit applications before the FCC. It hasn't made a decision on any of them. That process is moving very quickly. We anticipate, if all goes well, that there will be a decision made by the end of this year, maybe before. But it's very competitive, and there are 5 very different proposals. Constellation thinks it has a better mousetrap in that regard, and I'll explain that next. Well, I've told you about the fact that we don't disagree that the market is huge. But right now that market is unserved, and the user population is not really attuned to using satellites, to using this new equipment. The infrastructure is not in place. Essentially, the entire industry is being started from scratch. It's a great idea. It'll happen. The question is how fast and with what system and how complex. What are the building blocks to that? Constellation's approach was to look at Motorola, which was a fabulous technology on one end, and truly was designed to provide global communications, seamless global communications. But our opinion of that system was that it was maybe a generation too early. That in fact, you should grow the system as the market develops, rather than building what is ultimately the final design up front before you have anybody to use it. So what we did, we went back to the drawing board, and we asked what would be the best core team of strategic partners to put that concept together. And then how should we build it? And we asked how we should build it first. And the response was, let's put together the least expensive, yet economically viable system that we can come up with that uses off-the-shelf technology that meets the initial user's needs. And get that system in place as fast as we can, and then as the user population grows, build the system, increase the capacity, and expand in future generations. And the interesting point there is that these systems, because they're in low Earth orbit, because they're only 500 to 700 miles in altitude, have a degradation in their lifetime for a number of reasons that is typically expected to be between 5 and 7 years. So the trick here, from a profit standpoint, is to make sure that from the moment that you begin spending money, designing, developing, constructing, and implementing that system, to the moment that you begin receiving revenues, to then finally the point in time when you have to replace that system, say at the most 7 years out, not only have you recovered your capital and operating costs, but you've actually made a profit within that 7-year window. So our approach was to build a system that was inexpensive enough but had the capacity to make that happen. Next slide. Again, this is a little bit of a recap, but essentially the core team I'm going to describe, we believe has the basic elements to put the system architecture together. We believe that in order to build a basic system, a first generation system, the technology's here. It's been used, if not in satellites, in other technologies regarding communications for years. Minimize the infrastructure. Let's put it up as simply as possible. And complement the industry as it already exists. Let's not compete with the terrestrial infrastructure, the landlines, the cellular communications companies that are worldwide. Let's give them a complement to bridge the gaps between areas which are either underserved or not served at all by the existing infrastructure. Next slide. The team that we put together to be the core team comprises 3 companies. And I think you'd be very impressed. They're all small companies, but very powerful. Defense Systems, which is located in McLean, Virginia, is actually a world leader in microsatellite construction and manufacturing. In fact, to my knowledge, they're the only company in the world that has actually built and launched a constellation of microsatellites to provide voice communications. That system was launched by the Pegasus Orbital Sciences launch company and was in operation for about a year and provided tremendous returns to its customer, the Department of Defense, and gave us a tremendous technology edge to move forward in our concept on how to do that from a commercial standpoint. Pacific Communication Sciences complements DSI's satellite capability as a leading system engineering company on the ground. In fact, PCSI developed the systems engineering for OSAT's 3rd generation mobile system. They developed the prototypes for Inmarsat's next generation of user terminal, and are a leader in microchip technology and cellular engineering, and focused exclusively on the commercial market. International Microspace is developing a new orbital launch vehicle that will be capable of taking approximately 500 to 800 pounds to low Earth orbit. In fact, if I look a little bit like I have a 5 o'clock shadow, it's because we've been bidding on a proposal for the last 30 days to provide multiple launch services to the SDIO. And that proposal is due Tuesday, so we're heading down to the wire. But we believe we have an excellent product. The interesting thing about these 3 companies, that's true, we believe we have an excellent product. The interesting thing about these 3 companies, and I'll put them in contrast to some of our competitors, is that we don't necessarily plan to build the hardware for this system ourselves. In fact, the whole concept here is to make sure that the objective here is to provide a service. Ultimately, it boils down to will the consumer buy it? And that boils down to how good is the dial tone. Okay? So we're not going to get bogged down in making sure that we build the handsets or that we build the satellites or that we build the gateways. We're simply going to focus on the system's architecture. And then we're going to open it up. And we're going to allow other companies that come in to bid on that and provide it and distribute that worldwide. Before we leave this, I want to point out that this is the core team. What we plan to do, and we've been in negotiations for over a year, with a number of major telecommunications service providers worldwide. They will envelop this team and actually form an encompassing strategic equity relationship around these 3 companies. And then we'll capitalize on their financial capability, their market presence in countries worldwide, and their political capabilities. Next slide. This is a perhaps properly more primitive version of the slide that you saw presented by Motorola. Basic service, voice, data, facsimile to the individual, to the automobile, to airplane users, and then to remote areas on the ground. Our focus is not going to be the United States market exclusively. In fact, it's going to be worldwide, and we believe that perhaps the largest market is developing countries where the infrastructure is not already built. Next slide. Looks rather complex, but essentially when the full system is up, and right now we envision 48 satellites in 4 planes of 12 satellites each in polar orbit that would provide seamless global coverage. And the only areas where our system won't provide coverage is over large ocean bodies where the footprint, the circular footprint, doesn't reach an Earth station. Okay, one of the main differences between between our system and Motorola's is that we're not planning to provide inter-satellite links. And that reduces significantly the technical complexity and the cost of the space segment. Now, our rationale there is that that footprint on the face of the planet is approximately 1,500 miles wide. So the likelihood that there will be one Earth station within a 1,500 mile wide diameter, and within that footprint, at least one link to the public switch network is pretty great. And so the areas on the face of the planet where you're really not in a position to have that footprint link in with the existing terrestrial network are pretty remote. And we decided from a cost-benefit standpoint, we would leave that elementary system. All in all, we're excited, we're aggressive. We feel like David against Goliath, that's the name of the competition. And we look forward to letting the market decide. Thank you.
Thank you, Bruce. Three very interesting presentations from a most established company down to more entrepreneurial startup companies. I'd like to kick off a little question and answer session here by directing the first question to Dr. Swann regarding the handheld unit. Maybe this is more of an ergonomic technical question. I can tell you at SDIO, when we're out on the road, we use extensively the small Motorola handheld cellular phone. We call it the bat phone. And, but it only gives us an hour worth of time. Now, if you're sailing across the Pacific and IRIDIUM's up and working, how long does the battery last, and what can you do about recharging in environments where you don't have an adapter, doesn't fit the plug in the wall in Botswana, and the sun's not out? What do you do when you're in the middle of the Pacific and your hour's up or however long?
Is this working?
Yep.
It turns out that issue is on the forefront of cellular telephones across the world. That's not a unique issue for IRIDIUM or anybody else. It also turns out that Motorola has recently discovered that it's the largest purchaser of batteries, and so we are very, very concerned about that, and we are working that issue very hard. The general answer is that you should buy your telephone option, whether it's an IRIDIUM or whether it's a microtac bat phone, according to your needs. And Motorola sells a whole series, I don't want to get into the sales pitch, but a whole series of telephones, and they're based on battery size. And battery size relates to time to talk. And if you need a large battery, you buy a car phone and you hook it into a car battery. If you need a portable phone that's extremely light and you don't want to even notice it's in your pocket, you buy a bat phone and put it in your pocket. And you sacrifice on the phone. Now, specifically about IRIDIUM, we plan on having multiple options also. The reason this phone is this size instead of the microtac small size is the purpose of this is to be in the outback. And so we plan on having batteries that respond to requirements like our Dynatac, which is like 48 hours of standby and 6 hours of talk or something like that. We also plan on selling as an option solar cell recharge and connections into Jeeps and Land Rovers and standard 12-volt batteries, and et cetera, because we realize that if you sell a telephone like this to a rancher in the outback in Australia, he or she will need to charge the batteries. And so you set up a solar cell charging station in their back shed, and you have two batteries and you exchange them each day. There are ways to work the problem, and indeed battery is one of the large issues, and Motorola is aggressively pursuing it along with the U.S. government in a consortium and a whole bunch of other people around the world.
Thank you. Now I'd like to open it up to general questions.
This is to Dr. Swann. The front cover story in this week's Space News is about a falling out between Lockheed and Motorola on satellite design and construction. Are you optimistic that you're going to get the weight down to where you can use a Pegasus-type launcher? And will you talk about what's going on with Lockheed and possibly other contractors like Boeing with regard to satellites?
I knew that was coming. Everybody reads Space News. There are 2 or 3 things I'd like to say. First is, I've been in space development for 25 years, and every system you're in has problems. Personnel problems, battery problems, weight problems, launcher problems, et cetera, et cetera, et cetera. It's a tough business to be in. There is no doubt about it. It turns out that Space News has, a very reasonable news story. It hit the front page, and it dealt with concerns between 2 major teammates. You all have been in business many years. There are many issues that surface. I cannot validate one way or the other anything about the story, mainly because I don't have a clue whether it's true or not. I mean, literally, I do not know. I was down in Phoenix on Tuesday and Wednesday of this week, and a lot of talk, but nobody would fess up to any issues. So I don't know the answer to the specific question of Lockheed. Teammates. We have excellent set of teammates that have signed up and are committing and putting large amounts of funding of their own into the development of the spacecraft system. The way the system is set up is IRIDIUM Incorporated was founded to be the consortium to operate the system. They'll buy the satellite constellation, turnkey type operation from Motorola's Satellite Communications in Phoenix, which is like a prime in the DoD vocabulary. And then we have a whole bunch of teammates or subs, depending on the relationship we develop with each one. Lockheed is the largest, doing the bus. We have Raytheon doing the L-band phased array antennas. We have a whole bunch of other teammates doing each, their own parts. You can imagine the viability of a program, the size of this one, and the market for each of the product suppliers. We're talking, experimental satellites. We're talking qual models. We're talking about a constellation of satellites in the first 5 years, and the second round of constellation of satellites in the second block, third round. 40 or 50 years worth of sell and supplies. That's not a bad buyer. So everybody is interested in playing with Motorola's IRIDIUM concept. And indeed, everybody has issues. This particular one made it on the front page.
Next question, gentleman sitting up here in front.
This is for all 3 of you. Are you allowing encryption or encryption? This is for all 3 of you. We allow for any kind of encryption of your signal so that people can listen into your conversations. I guess right now that's not much of an issue, but in the future will definitely more of an issue.
The question was whether either any of the 3 companies are going to provide for encryption for privacy in people's conversation and message transmission and reception.
Well, we won't have conversations. We're data, essentially a digital system. The format is digital. It lends itself to encryption at the internal unit, decryption at either the network control center or all the way through the unit. I think the people in the encryption business would worry about decrypting end-to-end through terminals as a fairly high-risk way to do it. So that means some compartmentalizing at the network control center if there is that level of national security. But for most business-type encryption, it would be done here and decrypted at the other end. Now keep in mind the typical transmission here, as contrasted to a voice system, is about 100 milliseconds. And multiple packets could be sending multiple transmissions. So there's a low probability intercept in the first place, especially for military applications, down pilots and this type of thing, classified type work. We don't see it as a particularly big issue, but let me also say we're going to great ends in the system design to make sure that codes cannot be easily stolen. That's as much a problem or a concern to us as anything else when you look at some of the stolen cellular codes, etc. And we have, I think, a very workable, simple, but very hard to crash means to prevent codes from being stolen, which could open, of course, the door to further penetration into the system and breaking into messages.
In answer to your question from a Constellation standpoint, we do plan to provide that kind of service to particular user groups. I think it's important to note that, particularly in Constellation's case, we do not plan to have thousands of channels of capacity in the first generation of the system. It'll be something that is, in our opinion, balanced to reflect profit over and above the capital cost and operating cost of implementing the system. Therefore, we're going to be focusing on targeted user groups, both in this country and worldwide. That'll include governments, companies that do business around the world, and that have a need for secure communications. So we'll plan on tailoring our services to their needs, and that'll definitely be a consideration.
Three important points on the question whether Iridium will have protection, capability, encryption. Motorola is a major supplier of STU3 to DoD telephone, so we know encryption. Second point is the system, or the Iridium system, will be a digital system. So, a bit is a bit is a bit. It's not a byte or whatever, but anyway. And the third point that's extremely important to know is that the commercial world is going toward protection of voice and data because of the tremendous economic competition around the world. It only seems reasonable that as R&D chiefs travel to the CIS and to new opportunities around the world, that they would want to protect their data.
Next question. The woman in the green back there.
I have a two-part question. The first one is related to Mr. Parker, the design of the gateways. I'm very intrigued by ORBCOMM's gateway. And the second question is addressed to both Alan Parker and Mr. Krasolsky. Earlier, Courtney Stad was talking about commercializing space activities and pointed out that there's considerable government involvement even now. I would like to know whether either of your companies would be able to survive without contracts with DARPA or the Defense Department or other organizations as such, and if you could make it as truly commercial, private enterprises.
Let me address the gateways first. That only applies to you asked that question. The gateways are required to communicate to very rapidly moving satellites. They're moving approximately 17,000 miles an hour across the horizon, across the field of view. And as such, they have a sunrise and sunset standpoint in any place on Earth. We need to track those satellites as they come across. This is not new technology to do that. What is somewhat new about it from our standpoint is the question of, well, how do you know where to look? Each of our spacecraft will carry GPS receivers, so we'll know where they are, and we don't really have to have a phase-lock boom type system with a 15-degree arc. The accuracy doesn't have to be extreme. We use two antennae at each gateway for a very simple reason. Everything within the system on the ground is highly redundant, is highly 100% redundant. And as are the antennas. And they are mechanical devices, and they are prone, obviously, to wear and breakage. So, in fact, we will have a spare at each gateway. That is not required. For instance, international customers may not want to for that reason. They say, okay, we'll suffer the breakdown. We will operate both, however, at all times. with one of them acting as the backup. We lose a little bit of availability, but we have a very we'll store main spares right at the gateway. These are secure sites protected by fencing and very public, may I also say. I don't know if I've answered your questions, but they actually are tracking wastebaskets in the view. It looks like a great big aluminum wastebasket. Well, they look like dew-line devices because they have a radar over them. I forget the name of the structure, but it's a triangular type structure with a low resistant material that covers it. They'll be heated, weather protected, cool. They'll have ups at uninterrupted power supply. They do have a small rack area where the modems exist, and there's dual stream on all the transmitters and receivers and dual modems. And each of the gateways also acts as a subscriber terminal. We have other reasons for doing that. There is a possibility that we may be offering on a somewhat, it's not as good a system as the differential GPS that is provided over very short areas, but we're investigating the possibility of providing a downlink with differential GPS for those people who want some significant improvement over the dithered GPS signal. And typically you have to be within 200 miles. I'm getting off the subject here a little bit, but it is another possibility. With respect to the other question is government subsidies. Let's go back a ways. Orbital Sciences raised $50 million in a private offering to pay for the development of TOS. It also raised $75 million for the development of Pegasus. This is commercial money. This is not government money. The patents and the whole system is owned by Orbital Sciences. Yes, the government felt it had a need for this vehicle. Therefore, they contracted to be the first customers. This is the anchor customer concept. We're not getting rich off those anchor customers, I assure you that. But they were nonetheless important because they provided that recognition, support, validation, if you will, to the concept. And we obviously appreciate that type of support. With respect to ORBCOMM, there's not a dime, not a cent, nothing, zero of government money. And there's no commitment. It's all commercial, 100% commercial. Every cent that's gone in so far, every cent that will go in, and we are developing this to sell eventually to the government markets. But it will be a non-development item. Okay? They want it. We'll make some accommodations, but we're not going to rewrite the system for ex-government customer. And I don't want to alienate a government customer. We obviously would like to have it, but on the other, the market for this really is a commercial market, in my view. I mean, by 90% plus. So that's where we're focusing our issue.
That was an excellent question, and I take particular I take particular delight in trying to frame an answer for you. I want to go back just a little bit to my background. I actually started with a brief stint in private law practice, but then went to the government and ended up after the Challenger accident in the office of the Secretary of the Department of Commerce, helping to frame what is now the new National Space Policy. And that was the transition point in which we realized that in order ever to get space business off the ground, we're going to have to try to find ways to get the government to step back and let the private sector forces move forward. Part of the problem is you've got to have somebody who wants to buy the product. Okay? And in the launch business, I think that day will come. But in fact, right now, there are only a few companies around the world that need that kind of a service. So it's very difficult, and you have to rely to a much greater extent, not exclusively, to a much greater extent on the government to establish and then stay in business. The beauty of low Earth orbit communications is, I think, for the first time in space, an application that addresses mass markets. 30% a year growth worldwide in mobile communications is awesome. It's the largest growing market in the world. Okay? That's commercial. That's commercial in the truest sense of the word. And here is an opportunity to use a technology that doesn't have a second. There's not another technology that exists today that can address the market worldwide that low Earth orbit communications can. Okay? Now the nice thing about that goes back to other space-related businesses, and it gets back to your question about what is the government's role, is that when in fact this low Earth orbit market gets off the ground, we're talking about revolutionizing the way space is focused upon from a business standpoint. Motorola's system with 77 satellites and the requirement for replacements of a number of those satellites on an annual basis. Constellation's requirements for 48 satellites and the same kind of annual replacement cycle. ORBCOMM's replacements. What you're talking about is not only an opportunity for commercial competition in the truest sense of the word in providing launches for those satellites, but enough satellites that are the same, okay, that have to be mass produced to begin implementing in space the same kind of mass production technologies that we've been talking about for years in other industries. So we're not reinventing any wheel. We're going back to, for the first time, looking at other industries, and we have the kind of market that will allow us to take advantage of all the tools that we've built over the past 30 years and truly begin space commercialization.
And I'd just like to add, from a government perspective, having worked with Courtney Statt on the Commercial Space Policy Review, government support and government backing of a commercial space venture doesn't always guarantee success. And the one notable example is that last year, GeoStar, which was similar to ultimately a two-way message and communication servicing for mobile communication users, which had been around for, I don't know, 5-7 years, which had the firm backing of the U.S. government. The U.S. government bent over backwards to expedite FCC licensing, provide access to space on the space shuttle, and had a number of users across a number of U.S. government agencies. The company still went out of business because they just weren't able to do the normal things that you need to do in a business to stay afloat, to generate a profit, to expand your market and gain customers. So the government is not always a guarantee that a commercial space venture will last. It'll help. Now, from the government's perspective, now on a different hat, now that I'm with the Strategic Defense Initiative organization, we feel now that we directly benefit from the success of these three companies being able to, Bruce was saying, small satellites, being able to mass produce them. That reduces the cost for us as a customer and ultimately benefits the U.S. taxpayer, who's able to benefit from strategic military capability in space at a low cost, as in access to space, operation of small and expensive spacecraft, and so forth. So that it's a benefit to the U.S. government, and in some instances the relationship works well, but it's not a cure-all for every new commercial space venture that comes down the pike. So, next question, Dale.
Okay, I had sort of a two-part question. One was Motorola. Will IRIDIUM Inc. be doing a public stock offering? And if so, what's the time frame? And the other one is for Constellation. You were talking about a downlink or a station anywhere within 1,500 miles. I wondered how you vote if several stations show up within the same footprint and decide which one to take the link. So in whichever order you want.
Why don't I jump in real quick since I've got the mic? That's going to be a simple software question based on the strength of the link and which one has the, which one is in view, which has the best signal, so forth. As I mentioned, I'm a lawyer, so I'll leave more detailed answers to my engineers.
I'm really not qualified to talk about the financing, and I'm not going to say much. It turns out that IRIDIUM Incorporated is forming a consortium at the present time. If you have any questions, call them.
Next question, sir.
Bruce, you mentioned that the FCC is evaluating 5 different schemes for low Earth orbit. Can we talk about if they choose one of those, does that mean the rest of them are out of business? The next question is, how much is commercial, of that decision is based on commercial versus technical aspects?
First off, you're seeing 3 of the 5 concepts right here. So,
Actually, two.
oh, excuse me.
We're in
Yeah.
a different group.
Yeah.
Tough question, and I'm sure that my colleagues will want to chime in also. I think everybody's asking the same question right now. How is the FCC going to make this decision? As I mentioned in my remarks, from the very beginning, the FCC has had what is called an open skies policy. It started with the first domestic satellite application way back in the early 70s. And what they did was they said, we want to foster competition. We don't want to make a subjective decision. We don't want to pick and choose. And the government's policy to this day is to promote competition to the max. So they established a set of rulemakings by which there would be public comment on the applications. People would comment to criticize each other's technology, business plans, markets, approach, and so forth. And then, based on all of the public comment proceedings, the FCC would then go back and they would develop a rulemaking proceeding in which they would try to establish certain criteria for legal, financial, and technical capability, minimum thresholds. And then what they did was they decided, as long as there are no technical constraints, as long as we can figure out a technical way that systems can coexist and be compatible, and it still makes sense, then that is the approach we'll take. Only in a situation where systems are simply mutually exclusive and there's no way to broach that technical problem, will we try to find an alternative. And in that case, there have been alternatives. The only alternative in the satellite field that's ever been used has been forcing a consortium, and that was in the case of AMSC, which is the geostationary mobile satellite system. And that ended up in the courts because of the manner in which the Commission forced the consortium. There was some debate, and there still is, as to whether they had that authority. The other alternatives, if they couldn't simply license all of them, were to have a lottery, to have an auction, or comparative hearings. All 3 of those options raise very serious questions and would take tremendous resources. I think that, in my personal opinion, the FCC is not going to just license one system. I think they'll at least license 2. I think there will be increasing pressure for them to come up with a way to license everyone and let the market decide. That's our position, and that's the position that's been taken by Qualcomm, and actually that's the position that's been taken by all of the applicants, in fairness to Motorola as well. I think that the main difference is that, and I certainly would prefer Motorola to speak in more detail on this, that their technology, at least as it's presented now, and the frequency usage scheme is mutually exclusive with the other applicants. And so there's a disconnect there. And to the extent that we can resolve that issue, I still don't see any reason why the FCC can't license all of the systems and then let them either work among themselves to figure out what makes the most economic sense, or go off on their own and try to come up with 5 systems, and the one who gets there first wins.
We have time for one more question. The gentleman in the back.
As a person that was at the last Space Development Conference here in D.C., they were talking about a system in space using satellites to allow national beaver service. That's now in operation. Looking at current communications needs, specifically cellular, there's a whole bunch of the nation at this point that doesn't have any capability of using cellular. Is there any plans by any of the companies to help have a nationwide cellular service where anybody could reach anybody else any place?
Let's split the question into 2. I'll answer one, then pass it on to Earl or Bruce. With respect to national beeper service, two companies advertise nationwide paging. They should stop doing that. It is not nationwide. In the case of Bell South, they advertise 450 markets. I'm not quite sure what they mean by that. It's 175 for SkyTel. They do distribute the page on the outgoing basis, of course, is one way, via a satellite system to ground terminals from which the page or signal is stripped off and sent to a terrestrial tower. So most of the country is unreachable physically by a page. With respect to the cellular, there's maybe a two-way answer there. If you just need to message, that's exactly the market that we're looking for, is the ability to send and receive a message, critical message, not necessarily voice. In our case, it's not voice. At low cost any place in the country. Now, that's where you get into the IRIDIUM systems. Of course, they could do data as well. I don't want to take that away in any sense. We hope to be lower cost. But if you want to do voice, you have to go to what is called a big LEO system. Any place. But you don't actually have to do that. You could use the AMSC system in time, in 1994. That would cover the whole country. They claim to have interconnectivity to cellular. Whether they can do it at the same cost or economics, that's a different issue.
Well, I think the aspect of providing a pocket telephone any place, any time in the world probably includes the U.S. So I'd have to answer the question that yes, that this will provide the ability to communicate in Wyoming while you're fishing, or Baja, California, or out back in Australia. The other aspect is referring to the earlier question, reference the FCC. IRIDIUM feels very, very strongly that that the technical progress and competency of the design should be evaluated, that the commitment of the teammates on the proposal, in the sense of not only submitting a proposal, but how much have you done lately? What have you done for me lately? The commitment of time, energy, expertise, funding, etc. should be evaluated. And indeed, competition should reign in space as well as on the ground. Motorola loves, thrives, works for, and enjoys competition. And competition in space is necessary to provide the competitive success that we need in the U.S. space industry across the board.
Well, I'd like to thank our distinguished panelists for taking time out of their busy schedules to be with us this morning. Very interesting. Thank you very much. And this basically concludes the revolutions in global communications part of this track. We'll now break for lunch and we'll reconvene at 1:30 for a panel on state space business initiatives. Thanks a lot.